Hello. This video is for IXL activity 8.V.5. It is titled Evaluate One Variable Expressions. This activity has a 3-character code of V77. In this activity, we're going to put together a lot of what we've learned so far through the first chapter since we started this course. And that's going to be, first of all, what does it mean to evaluate? Well, we know that evaluate means take whatever value they give us for the variable, substitute it into the expression or the equation, and actually come up with an answer for that equation, or technically expression. Once we throw that equal sign on there and we have an answer, then we suddenly have an equation. But at any rate, but it's just the expression we're trying to solve, so technically they are an expression. Also, we're going to be looking at order of operations. Please excuse my dear Aunt Sally, where we're going to do parentheses followed by exponents. Then we're going to do all the multiplication and division, and then we're going to do the addition and the subtraction. In here, we're going to find some addition and subtraction of integers, so that's positive and negative numbers. And also along the way, we're going to find some multiplication of integers, so multiplying positive and negative numbers. So this activity pretty much is almost like a review of a lot of what we've learned already. So let's go ahead and get started. So on our first question here, it says m plus 6. Well, what is m? Well, we know here that we're told that m equals 12. So we're just going to substitute in the value of 12 for m, and 12 plus 6 is 18. So not too difficult to start off with, right? On the next one, c equals 10, and we're going to substitute the value for c. We're going to substitute the value of 10. So we have 10 minus 5. Now, most of us know 10 minus 5 is going to equal 5, right? We could look at this as 10, change the subtraction to addition, and take the opposite of the number that follows. So negative 5, so 10 plus a negative 5. They are different signs, so it's addition of integers. They're different signs, so we're going to subtract. 10 minus 5 is 5, and 10 has the greater absolute value than negative 5, so we're going to make the sign match whatever the 10 is, which is positive, so positive 5. On the next one, g is equal to 2, so let's rewrite this. 5 plus 7 times g. And I'm just going to put in parentheses whatever g is. In this case, it's 2. So we know through order of operations that we must multiply before we can do addition or subtraction. So we're going to go 5. We're going to leave the 5 plus alone. We're just going to do the 7 times 2, and that's going to be 14. And now we can go ahead and add 5 plus 14 is 19. So our answer is 19. On the next one, it says negative v, or I like to read this here negative sign as the word opposite, right? So we're going to use this as opposite of v. So let's make our opposite sign, and for v, we're going to substitute in 19, and let's read this as the opposite of 19. Well, what's the opposite of 19? The opposite of 19 is negative 19. Next question, 2h. Well, this one here shouldn't be too hard, right? This means 2 times whatever h is. Let's plug in that 0 for h, and anything times 0 equals 0. So we know that our answer here is 0. The next one's an exponent. So we're going to take whatever c is and square it. Well, we see that c is 0. Well, this isn't too difficult either. This just means 0 times 0. This is the base. This is the exponent. 0 times 0, multiply itself. The base, the number of times equal to the exponent. So we have 2 zeros, and 0 times 0 is 0. On this one here, let's go ahead, and we know that g is equal to negative 1. But so that we don't get our negative signs mixed up and miss something someplace, let's use the strategy of rewriting the expression, and wherever the variable is, we're going to put a parenthesis to hold whatever we're plugging in for that variable, and then from there we'll do the math. So we have negative 14 times g minus 2. I've not really been paying attention to this g equals negative 1 yet. I'm just rewriting this right here, but wherever the g is, I'm just putting a parenthesis. Now I'm going to plug in whatever the value of g is. In this case, it's -1. So we have to take care of this multiplication before we can do this subtraction here, right? So let's go ahead and do that. Negative times negative is going to be a positive, and 14 times 1 is 14. Now let's bring down this -2, and 14 minus 2 is 12. If you really wanted to do that, you could say 14 plus -2. Same difference. We'd still get 12. So our answer here is 12. Here we have 3 times the quantity of, a little bit of a math vocabulary lesson or academic language lesson, you might say. These parentheses right here, we read the parentheses as the value of. So parentheses in mathematics are read as the value of. So we would say 3 times, because there's no sign here, so we know it's multiplication, 3 times the value of p minus 10. If somebody were reading that to me out loud and I needed to write it down and they said 3, and I'd write down 3, they say the value times, I'm thinking, okay, multiply, the value of, I'm like, oh, I need parentheses, and then whatever they say next goes in the parentheses, p minus 10. All right, so a little bit of a academic vocabulary lesson there for mathematics. Parentheses are read as the phrase, the value of. So I'll go ahead and erase this here, and we'll get started on that. So we have 3 times the value of, and I'll put a smaller parenthesis in here to hold the p, minus 10. And then let's plug in whatever that value of p is that goes there, and that's 8. So let's deal with the parentheses first. So I'm focused on 8 minus 10. That is the same as 8 minus 10 is the same as 8 plus, change the subtraction to addition, take the opposite of the next number, -10. So now I know that they are different signs, so I can subtract the greater absolute value from the lesser. So 10 minus 8 is 2, and 10 has the greater absolute value, so I'm going to use the sign that goes with it, so it's a -2. So I end up with 3 times -2, because 8 minus 10 is -2. Now I have multiplication of a positive times a negative, so I know positive times negative equals a negative, and 3 times 2 is 6. The solution here is -6. Next one, a little bit of a lengthy one. I kind of gave it its own page instead of trying to squeeze 2 problems onto one page. Let's just rewrite it first. So the opposite of whatever x is, minus 1, close the parenthesis, minus 3 times whatever x is squared. So I just rewrote this expression and just put parentheses for where x is at. Now x is -4, so let's plug in -4. -4. So I need to do, let's see, I need to do what's in the parentheses first, right? Please excuse my dear Aunt Sally. So I'm focusing on this part right here. So I need the opposite of whatever -4 minus 1 is. So -4 minus 1, I can think of that as -4, change the sign to addition, make this the opposite of 1 is -1. Now, same sign, so they're both negative, so the answer will be negative, and that means since they're the same sign, I'm going to add them together, and that's 5. So I end up with -5 minus, and then 3 times whatever this is squared. So this square, -4 squared, is going to equal, take the base, -4 times -4. Negative times negative is positive. 4 times 4 is 16. So this is going to be 16 right here. So I took care of that exponent. So this is the opposite of -5. Well, the opposite of -5 is +5. And minus 3 times 16. Well, 3 times 16, I'm going to look at that as 3 times 15. I'm going to think of, take that back, I'll rewrite it this way. I want to show my mental math on this. I could just spit the answer out, but let me show you what's going on in my head. I'm thinking that 16 is the same as 15 plus 1. And I know that 3 times 15, well, 15, in my head I'm thinking 15 plus 15 equals 30. And another 15 would be 45, right? So that would be 45. And then 3 times 1 is 3. So 45 plus 3 is 48. So the mental math in my head to get to 48, there it is right here. And then now I have 5 minus 48. I like to look at that as 5 plus, take the opposite of 48, which is negative 48. Now I know that they are opposite signs. So this means that I'm not going to add, I'm actually going to subtract. 48 has the greater absolute value than 5. So I'm going to do 48 minus 5 to get 43. So I have 43 there. And 48 has the greater absolute value. So it's a negative number. So my answer is going to be negative. So negative 43. If you're unsure about all of what I just happened there, be sure to go back and watch the video, especially on the addition and subtraction of integers. Evaluate the expression for h equals 2. So let's plug that in. Opposite of 3 times whatever h is, and then all that squared, plus 10 times whatever h is squared. So I just rewrote the expression, leaving wherever the variable h is, leaving parentheses so I can plug it in. So I'm going to plug in that value of 2 in both those parentheses. Now I need to deal with, let's do what's inside the parentheses here. So the opposite of, and what's inside the parentheses is 3 times 2. That's going to be 6, and that has to be squared. And then plus 10 times 2 squared. Now let's take care of the exponents. So I have the opposite of whatever 6 squared is. Well, 6 times 6 is 36, plus 10 times whatever 2 squared is, and that's 4. So now I have the opposite of 36, which is negative 36, plus 10 times 4. Well, positive times positive is positive. 10 times 4 is 40. And now I have integer addition. One's negative, the other one's positive, so I know I'm going to actually subtract the greater absolute value of 40 and subtract from it the absolute value of negative 36, which is 36. That's going to give me 4. So I have 4 there, and 40 has the greater absolute value, so it wins out. It's positive, so my answer is positive as well. Here we have they're getting longer, aren't they? But again, start by rewriting the equation. Whatever q is squared plus 24, and I'm getting ahead of myself because I'm seeing that 24 plus 1. What I want to do is I want to go ahead and add it now, but I'll go ahead and wait. 24 plus 1 plus whatever q is, which is negative 5. So let's plug in for q. Negative 5 squared, this means negative 5 times negative 5. Negative times negative is positive. 5 times 5 is 25. So I end up with positive 25 plus 24 plus 20 plus 1 plus negative 5. Okay. Now, see some easy math coming up right here. 24 plus 21 is what? 25, right? And 25 plus 25 is 50. So that plus negative 5. And if you really want, you could change this also using the same strategy I used to change subtraction to addition. If you wanted to, you could say 50, change the sign to subtraction, take the opposite of the next number, 5, and then for some, 50 minus 5 equals 45. Might seem a little more simple. We could have said 50 plus negative 5, and so we know that they're different signs, so we would have to subtract 5 from 50, which is 45. And 50, the positive 50 has a greater absolute value than the negative 5, And since the 50 is positive, our answer would be positive as well. All right, then we come upon some decimal numbers here. And you might think, oh man, decimals. But look, check this one out. This one's actually kind of easy, right? 0, d equals 0. So no matter what this is, we're going to get d squared is going to be 0. And then we're going to multiply that 22.6 to it. And anything times 0 is 0. So the first one, we really don't have to do a whole lot of calculation because we know we're going to square 0 and get 0 and then multiply it times whatever number, in this case 22.6, and we'll still get 0. So hopefully you're looking at this next problem and saying, well, wait a second, C0, so this one's probably kind of easy too? Maybe. If we put a 0 right here and square it, that's going to be 0, and then we multiply it times 34, and that's going to be 0. And then if we plug in 0 right here and multiply it times the negative, well, I say negative because if we change that to plus, then this would be negative 14.1. So either way, whether we look at this as minus positive 14.1 or plus a negative 14.1, it's still going to be, you guessed it, 0 because we multiplied it times 0. And then we bring down the plus 17. Well, now we got 17. We got a couple zeros. 0 minus 0 is 0. Plus 17 is going to equal, 17. So if I erase all of this here, hopefully you could look at a problem like this and realize right away this term's going to be 0 and this term's going to be 0, leaving me with nothing but 17. And 17 would be your answer. Final question here. Nope. Z is not equal to 0. It's not going to be that easy. And for this one here, honestly, I'd suggest break out a calculator for this one. But let's first go through the strategy of rewrite the expression and plug in the variable. So negative 5.4 times, and I'm just going to go ahead, instead of parenthesis there, I'm going to take a step forward and just write this in now. 4.8 is what z is equal to, right? Minus 3.9 plus 2 times whatever z is, which is 4.8, and that needs to be squared. So at this point here, I think I'm going to go ahead and actually use a calculator. I have negative 5.4 times, and then I want to do the 4.8 minus 3.9, 4.8 minus 3.9, and that's going to give me 0.9, and then plus 2 times, now let's go ahead and do this 4.8, that's going to be 4.8 times 4.8, right? I'm going to multiply that. So on my calculator, I actually have a exponent button, power of 2, so I'll just push the square button, and that's going to give me 23.04. Now I can do the negative 5.4 times 0.9, so negative 5.4 times 0.9 equals negative 4.86. Add that to, now I need to do the multiplication over here of 2 times 23.04, and that's going to give me 46.08. And then from here, I think I'll do the rest by hand. So I do have addition of decimal numbers. Actually, we really haven't gotten into decimals yet, so I'm kind of taking a peek ahead. We've just been working with integers, which are non-decimal numbers. The key thing here is we can use the same strategy. We just have to understand that we need to line our decimals up whenever we add or subtract decimal numbers. So let's go ahead and take a look at that. We're wondering what's this going to equal. Well, I am adding 2 values, and they are different. They're different signs, that is to say. And the first is negative, the second is positive. So I know I'm going to need to actually subtract instead of add. The one with the greater absolute value is going to be the second one here, which is 46.08. And that's not a very good 0 there, is it? Let's make it bigger, 0.8. And the lesser absolute value is going to be the 4.86. So 4.86. And notice that I line my decimals up because I want to keep the decimals help show place value, what each number, what place value each number's in. So we do want to line them up so that our ones place and our tenths place and our hundredths place, that all those values are lined up for us. And I actually want to subtract. So 8 minus 6 is 2. I need to borrow here. 6 is going to become 5. The 0 is going to become 10. 10 minus 8 is 2. And 5 minus 4 is 1. And bring down this 4 here. So I get 41.22. Now the question is this a positive number or should it be a negative number? Well, we see that the greater absolute value belongs to the positive number. So since the greatest absolute value between these two values is positive, our answer is going to be positive as well. That's 41.22. All right. So those are all of my examples for 8.V.5, evaluate one variable expressions. Remember, my biggest piece of advice on this is to first rewrite the expression and using parentheses wherever the variables are, then plug in the variables, and then from there go through your order operations and your adding and subtracting integers, sometimes decimals, and your multiplication and division of positive and negative numbers. Good luck.